I do not like what this unit is doing to my relationship with the letter T. It is in turmoil and it is tumultuous at the moment, the present time, one might say. Anyway, that's my clever quip at some ungodly hour of the night. Okay, so this video is not video one, it's video two. But this is the prequel to the actual t-test. So now we know, like, okay, we've got this hypothesis, we've got a null hypothesis. We know what the t-test is sort of aiming for, right? And now we have to look at all of those other weird things with t's and p's and degrees, and how they're going to come together to make this magical t-test that's going to tell me whether or not my data is significant. So these are the terms that you're going to end up seeing and the things that you're going to have to input in order to find this t-test. It's a little tedious that wasn't even on purpose, but it was good. Anyway, I digress. So these terms you are definitely going to see, and you're going to have to reference them all the time when you're doing a t-test. And it's very easy to confuse all of them. But once you get the hang of it and you see this magical chart that you are given on the test, you're going to be so excited. And by so excited, I mean mildly amused. Okay, so let's start with degrees of freedom. There it is. So degrees of freedom is telling you, okay, these are the number of independent pieces that I have. So basically, this is the number of data points. Let's say I have 15 data points. Great, my number is 15. But it's taking into account, like, okay, there's a little bit of wiggle room here, right? I might need to have a certain number that stays the same, but there's always going to be a little wiggle room. Like, I could change one of the terms and it wouldn't affect my overall average, right? So the way that this is computed, right, is degrees of freedom is n minus 1, n being the number in your sample minus the number 1. There's some good reason, I mean, lots of them, for why this happens. I'm willing to just accept it. I'm willing to say, you know what, math, you got me, and I trust you. However, I think I added at the end in the notes of this PowerPoint, if you want to go check it out, please enjoy. Okay, more on degrees of freedom. If you have two sets of data, right, like we did in class when we were looking at vegans versus meat eaters, right, we have two sets of data. So we actually end up adding those two samples together. We add N1 or set 1 and N2, those numbers. And then we're going to subtract 2 from that because now we're dealing with two sets of data instead of one. Hi, honey. Okay, next. So the t-value is the next thing on the list. And I think that caused a lot of confusion in class today because the t-value is not the result of the t-test. The t-value is something that is given to you. It's sort of like a marker, like a stamp of how good your data is, right? And how likely it was just due to chance, right? That's the t-value. And you're going to be given that t-value. You don't have to calculate it, but the t-value is actually used to determine the results of the t-test. It is not in itself the results of the t-test, right? So t-value, t-test, two different things. We use the t-value to conduct the t-test. Mozart's the perfect dog, honey. Okay, what does t mean? So t-value represents the difference between two groups, so like between the vegans and the meat eaters, right? And the differences within those groups. So like we have to take into account not only that there's differences in the average of muscle mass gain between vegans and meat eaters, we also have to take into account that there are going to be differences within the individual groups themselves. So outliers in the data for meat eaters or outliers in the data for vegans, that's going to affect the standard deviation in those groups. That's basically going to affect, okay, well, for the vegans, how well does the average represent all the data points? For the meat eaters, how well does the average represent all the data points, right? And and all of those things are being taken care of, sort of rolled into like one nice big present with a bow on it, in the form of your t-value. And that's what you're being given. So all you have to know is that the t-value represents the difference between the two groups being tested, And it also accounts for any differences within the individual groups. So t-value. Not bad, not bad, okay? It's not that bad. T-value numbers. So we talked about this a little bit in class, but if the t-value, because we're doing the difference between the two groups, right? If you're the researcher, you're thinking to yourself, like, I want this. Like, if I did research on vegans versus meat eaters, and I am a hardcore PETA member, if you don't know what that is, look it up. So I want my results to be significant. I want them to be a result of the diet that I'm researching. I will be sad if it's due to some sort of fluke, right? So my t-value numbers are very important to me, because if there's a large difference between my two averages, then I'm looking good, right? And if there's little variation, if there's very low standard deviation in my independent groups, then like I'm looking really good, right? Because my individual groups have got really good data, and then the difference between my two groups is pretty high. This makes for a high t-value, which means I'm probably looking at a difference between my two groups that is a direct result of my experimental design. The difference that I see between meat eaters and plant-eating bodybuilders is because of their diet, and it's not because of some random chance. That's what it means when you have a high t-value. When you have a small t-value, right? Not so much. A small t-value is kind of saying, like, it's more likely that your results were due to chance. Okay, and we'll see what that looks like in a second. There's a whole chart. You're gonna love it. But there are more letters first. This is the p-value. The p-value, again, you don't have to calculate it. The only thing you need to know about the p-value is that this is the probability value. It's sort of like, what value are we willing to accept for wrongness, right? And I think we talked about this a little bit in the other PowerPoint, but it's too late for me to remember anything, right? So basically what we're saying is 5%. So this number right here where my mouse isn't working, right? That number of 5% is saying I'm willing to have like a 5% roundabout that this may have been due to chance. Anything more than 5% is unacceptable, right? Any indicator that tells me that the results of my study, there's a 5% or greater chance that it was due to chance, right? Due to some random thing. I have to reject it. It's not good enough for me. I need 95% confidence level. And that's really what we're going to be going with when we look at our t-charts, because that's what we accept in biological sciences. That's pretty like our go-to standard, right? If you can get like a lower p-value, like a 0.25, like woo, your data is awesome. Okay, so the question now becomes, what am I going to do with this chart? What am I going to do with all of this information when I get it? I don't like it, right? That's fine. There we go. So we can calculate t. We don't have to, because we're going to be given t, right? And we can compare it to these critical values in a chart. The picture I'm about to show you is brilliant, right? I didn't make it. So here we're looking at p, right? And there's our p-value right here at 0.05. This alpha is saying, like, that's our confidence level. Like the alpha dog. He's confident, right? He's the leader of the pack or something. Where'd that go? Okay. Another thing that you're going to see when you are looking at your chart is this critical value, right? So the critical value is a point on the t-chart that you're going to find. I'll show it to you. And it's basically a benchmark. It's like, okay, for the number of people you have, so for your degrees of freedom and this percentage that you want to fall into, so for your degrees of freedom and your p-value, you've got to get higher than this critical value in order to be considered significant, right? It's kind of like, in order for you to make varsity football, you have to have this many good things they do in football, right, in order to pass, right, in order to like get past that threshold and get on the team, right? We want our data to get on the team of statistically significant. right? And it has to pass, it has to be greater than this critical value in order for us to say, yes, it's significant. And when I say, yes, it's significant, that means I can reject the null hypothesis. Bye-bye, naysaying null hypothesis is what I want to say. Ooh, look at the chart. I don't like that chart. Maybe I do. You love this chart. So the chart is going to show you your p-value right here. We're always looking at 0.05. Here are your degrees of freedom, right? So if you go back to that earlier PowerPoint, which you may have tried to scour from your memory, right? We had 30 different test subjects. Or I'm sorry, we had a degrees of freedom of 30 because we had 32 subjects from 2 different sets. So 15 plus 15 minus 2, you got it. You can go back a few slides and you'll see degrees of freedom. So we got our degrees of freedom at 30. I'm going to now say, like, we did something else, and now we have degrees of freedom of 10, right? So you're going to look over here, and you're going to see your 10 degrees of freedom. We know that we want to be within this p-value. So when I match those two things up, I get this value, 1.812, if you can see that. That's my critical value. If I get a t-value that's above that, that means toodaloo null hypothesis. I'm going to null you, right? You're significant. If it's below 1.812, then, right, it more likely happened because of chance and kale. All right, so I've left you in this PowerPoint some examples. This is going to take you through the entire process of p-values and stuff like this, and this is exactly what we're going to be doing in class tomorrow. I highly, highly, highly recommend that you bring that yellow packet that has everything outlined on the front of it that starts with error bars. It's really going to help you to get through p-values, and then we're going for gold. We're going for our studying time being significant. P-test for your test, which is Friday.